Welcome everyone. The question that is shown on the screen is CBSE sample paper 2025 question number 6 in a series LCR circuit. So welcome, this is the question from alternating current. The voltage across the resistance, capacitance, inductance is 10 volt each. Okay, so there is a LCR series circuit and the voltage across the resistance, capacitance and inductance is 10 volt each. If the capacitance is short circuited somehow, the voltage across the inductance will be what it will be, that you need to find it out. Okay, so let us draw this. This is inductance, this is capacitance, and this is resistance. This is connected to an AC source, LCR circuit. Okay, VT, alternating source. So here obviously the voltage drop across the resistance L, voltage drop across the resistance R, and voltage drop across the resistance C all are same and all are equal to 10. Okay, here the same current is flows through all. So obviously this will be capital I multiplied by the reactance of the inductance, capital I the current multiplied by the resistance, capital I multiplied by the capacitive reactance, okay, equal to 10. So from here we obviously find it out what is the value of the XL, R and XC. Okay, so from that obviously here IR equal to 10 volt. So XL, if you want to find it out, that is 10 by I. Okay, and XC if you want to find it out, that is also 10 divided by I. Resistance you want to find it out, that is also 10 divided by I, the current. Now in the second circuit it is said just the capacitance is short circuited. Okay, so the capacitance is not in the circuit, only L and R in the circuit. L and R in the circuit with the same source, same thing, same source, same thing. Then what is the voltage across the inductance, that you need to find it out. Okay, so what is the value of the Z here? Z prime we can say. If I say Z, then Z is the previous one, that is R square plus of XL minus of XC whole square. Z is the impedance. Since XL and XC it is equal, okay, so it is R square entirely. So Z is equal to R. The circuit is completely resistive here. Okay, so from that if I want to find it out what is the value of the current, then we can say V by Z. Okay, so that will be V divided by resistance R. Okay, V divided by resistance R. This is the thing. So R is 10 by I. R is 10 by I, so it is 10 divided by I. So from here obviously I equal to, see, very interesting thing, VI divided by 10. Okay, so I cancels out, so the V will comes out as a 10. V will comes out as a 10. If the capacitance is short circuited, the voltage across the inductance. Okay, voltage across the inductance. Okay, so from that XL, what is the value of the XL? XL equal to now simply 10 by I. So XL equal to, we can say this is 1 ohm. XC is also 1 ohm. XC is also 1 ohm. I am not talking about the capacitance, okay. I am talking about capacitive reactance, that is also 1 ohm. Capacitance is something else, inductance is something else. If I say R, then R is also 10 by 10. That means R is also 1 ohm. Okay, so what is Z prime? Now obviously C is absent there. Since C is absent there, so Z prime, that is for this second circuit, that is R square plus of XL square. What is the value of the R? R is 1, so it is 1 square. What is the value of XL square? That is 1 square, so Z square is root 2. Okay. And what is the current now? Let us say this is I prime. I prime equal to voltage, same voltage is used here, divided by the Z prime. So the voltage divided by Z prime is root 2. Voltage we have just calculated, it is 10. So it is 10 divided by root 2 volt. So now the current is changed, and that is I prime, and the value that we have just calculated, that is the value is 10 by root 2 volt. No, that is the current. 10 by root 2 ampere, that is the current I prime. What is the voltage across this inductance? That is the voltage across this inductance is I multiplied by XL. I is 10 by root 2, and the XL is 1, so that will be 10 divided by root 2 volt. Okay, now option C is the correct option. Thank you, all of you.